Let's use the same problem that we've been using in previous lessons for this next one. So we're going to use the same graph. The velocity of a particle moving on the x-axis is given by this graph. Another thing we can be asked to do is to write equations based on our little graph. Generally, these will just be simple linear equations. Actually, I guess they're expressions. Write expressions for the particles, acceleration, that's a of t, velocity, v of t, and distance, x of t, from the origin that are valid for the time interval when t is between 0 and that should be a 2. Now this funky wording here, valid for the time interval 0 to 2, all that means is it means that we're only looking right here when t is between 0 and 2. We don't care about anything else, which is good because this is a different equation for this line than that line, than that line, than that line. So let's just start off at the top. Notice, by the way, that distance is going to be x of t, not p of t. Make sure that you write that correctly at the end. Let's see what we've got. So first things first, we have a graph of velocity. What is the equation of the line from 0 to 2? Let's go ahead and write this in y equals mx plus b form, or v of t equals mx plus b. First thing that we want to know is our slope. Second thing we want to know is y-coordinate of the x-intercept. So I can see right here that the slope 1, 2, 3 over 2. And I can see that the y-intercept is 0. I could also have done this by observing that there was a point right here, and doing it with the formula that looks like this. Y minus 0 equals 3 halves, x minus 0, end up giving you the same thing. Just make sure you substitute the vt, which is what we're looking for, in for that y. So once we have an equation for velocity, or an expression, I should say, for velocity, then we know that the acceleration is the derivative of v of t. So we can just do that derivative. If v of t equals 3 halves x, then a of t is just 3 halves. Going the other way, x of t, which remember is position, is the antiderivative of v of t. Oh, there's one piece of information that I forgot to write in the problem. When t equals 0, the position is -1. So x of t is the antiderivative, so let's take the antiderivative of v of t. Whoops. I just need to go back up here. So notice up here that I have an x here, but I have a t here. That means, because this is supposed to be in terms of t, that means I should have a t right there. Likewise here, x is my variable for position. My input variable here is t. That should be 3/2 t dt. So when I take the antiderivative, I'm going to add 1 to the exponent, divide by the new exponent. This is plus c. Three halves divided by 2 is 3/4. But the thing is, we don't want to just leave this plus c here. So we substitute in when t equals 0, x of 0 is -1. So that means that -1 equals 3/4 0 squared plus c. c equals -1. So our final equation is right like that.